For this problem, we're going to go over Newton's second law. And now that we've covered Newton's second law, which can be written as F equals ma, we have an equation, and that means we can do some physics with actual real numbers. And for the purpose of this, it's important to remember that force is measured in newtons, and 1 newton equals 1 kilogram times meters per second squared. And you can do all of your unit conversions in that set of units. For this problem, imagine that a skydiver jumps out of a plane, and when his parachute first opens, his parachute is exerting an upwards force of 500 newtons in the upwards direction, and the skydiver himself weighs 600 newtons, and that's the force that gravity is exerting on him, and that's roughly equivalent to 60 kilograms. So you know his mass, and you can figure out the net forces on him. So understanding this, try to figure out what his acceleration will be. And I'll give you a few seconds to work on that. So first we start by finding his net force, because in our equation, F equals ma, we have an answer for his mass, and we can figure out his force, and then that will let us find his acceleration. So his force is going to be 500 newtons, and we're going to call the upwards direction the positive direction. We could do it either way, but that's a fairly normal thing to do. And then minus 600 newtons, which is 600 newtons in the downward direction. So that equals negative 100 newtons. So you can see that negative 100 newtons equals 60 kilograms times acceleration. And that becomes negative 100 newtons over 60 kilograms equals acceleration. So now we need to do unit conversion to make sure we actually got this right. Negative 100 over 60 is approximately negative 1.66 repeating. It's actually exactly that. And newtons over kilograms is kilograms meters per second squared over kilograms, because that's what we said the conversion factor for newtons was. The kilograms cancels, just like we did in units conversions, and that leaves us with meters per second squared. And that means that our acceleration, which was negative 100 newtons per 60 kilograms, comes out to be negative 1.66 repeating meters per second squared. And it's negative, which means it's in the downward direction, which makes sense because he's falling. There's more force being exerted on him by gravity than by the parachute. And then we know that it's 1.66 because we did our division, and meters per second squared is the right unit for acceleration. So all of that checks out. Now that said, if his parachute suddenly broke, how much would he be accelerating? So try to draw a free body diagram for that one and calculate it out yourself. And once again, I'll pause the video, and then you can take a few seconds and then go back and we'll go over it together. Okay, hopefully with some idea of what's going on there. Let's start by drawing our guy. Our guy now no longer has a parachute. The only force on him is the force of gravity, which as we said is 600 newtons in the downward direction. And he weighs 60 kilograms. So this one's a little easier. We don't need to add forces together. We just know that negative 600 newtons. You have to remember to keep your signs accurate. It's a negative number because it's in the downward direction. So downward direction means negative number. And we could have defined that differently. It doesn't actually matter how you define it. It just matters that however you define it, you keep working on it in the same way. So going back to F equals ma, which is the equation we're using here, 600 newtons equals 60 kilograms times acceleration. 600 divided by 60, because we can divide both sides by that, comes out to be 10, so negative 600 would be negative 10. So negative 10, and newtons divided by kilograms, we already said is meters per second squared. So his acceleration is negative 10 meters per second squared, also known as 10 meters per second squared in the downward direction. Now this is accurate because you might not know it, but the exact acceleration of gravity is 9.81 meters per second squared, which means our example is pretty realistic. His falling rate of 10 meters per second squared is pretty close to the 9.81 meters per second squared of gravity. And in future calculations, you can use either one. It's close enough for most of the physics you'll be doing. And this tells you how fast an object will fall in free fall. And you can actually use that to calculate the force, because this acceleration times this mass should give you the force, because force equals ma. You can use that in any direction you want. So this is a very valuable concept. I'll be using it more in later lectures. But for now, I hope you understood what's going on. And if not, I once again invite you to go back and look over. And once you've got it, you're ready to move on to the next video.